Number 1 gives us an inequality and asks us to select all of the values that are part of the solution. So you have a few different ways you can do this. You can take each of these values and plug them in, and you would like this side to be less than or equal to the other side. So when you plug the value in, if you get that the left side is less than or equal to the right side, then it's a solution. So that's one way. You can just plug them in. You can also solve the equation like it's an equal sign. So we could just divide both of these by 2. So we could get 3.5x plus 3, and then solve for where that's equal to 3x plus 2. So then we could subtract 3x from both sides, and this is going to give us 0.5x plus 3 is equal to 2. Then we could subtract 3 from both sides, and we get 0.5x equals negative 1. So then we could divide by 0.5, and we get x equals negative 2. So this is called the boundary. So this is where both sides are equal. So we know that this one will be a solution to it. So then what we want to do is we want to plug in a number on the other side of negative 2. So on one of the sides of negative 2. And that will tell us if the numbers down here. So if we plugged in negative 3, we would find out if the numbers less than negative 2 are solutions, or if we plugged in a number higher than negative 2, we would find out if the numbers greater than negative 2 are a solution. So I'm just going to plug in 0 because it's usually pretty easy to plug in 0. And so let's plug in 0. So 7 times 0 is 0. So then we just get 6 divided by 2 on the left side, which is 3. And then we're going to see if that's less than or equal to when we plug 0 in over here. So 3 times 0 is 0, plus 2 is 2. So this says that 3 is less than or equal to 2. And that is a false statement. So when we plugged in 0, we got a false statement. So this is not part of the solution. So what that means is that all of these values are going to be part of the solution. So our solutions are numbers that are less than or equal to negative 2. So that means negative 3 is going to be a solution, but all of these numbers that are bigger than negative 2 are not solutions to this inequality. Number 2 asks us to find the solution set to this inequality. So it's similar to the last one, just not specific values. So we could go ahead and solve this one. So x minus 3, and really actually before we get started on this, so you can take a look at this. This symbol does not have an equal sign with it, so we can rule out C and D right away. So then, since these two values are the same, either the x's are going to be less than a half or they're going to be bigger than a half. So what I'm going to do is I'm going to plug in 0, which is less than 1/2. So if this is a solution, okay, then the numbers less than a half is our solution set. If this is false, then the numbers greater than are going to be our solution set. So let's plug in 0. So 2 times 0 is 0. Minus 3 is negative 3. So then let's see if that's greater than when we plug 0 in on this side. So 2 times 0 is 0. So we have 0 minus 5 is negative 5 divided by 2. So as a decimal, that number is negative 2.5. So this is saying that negative 3 is greater than negative 2.5, which is false. So when we plugged in 0, we got a false solution, okay? So 0 is part of the less than 1/2 category. So that's going to be false, so B is true. And let me just write that on a number line so that maybe it makes more sense. So we know that 1/2 is the boundary. So now I just plugged in x equals 0. And what happened was when I plugged in x equals 0, I got a false statement. So this side, or numbers below 1/2, are not the solution. So that means that numbers up here are the solution. These ones are going to give us the true statements, and these are the values that are bigger than 1/2. Number 3, here's an inequality. -10 plus x divided by 4 plus 5 is greater than 7x minus 5 divided by 3. And this wants what value of x will produce an equality to this statement. So what's really the boundary line here? And this is a pretty intense inequality. So trying to solve this is going to be a lot of algebra. We're going to get quite a few decimals if we try this, because even if you just divide these, so -10 divided by 4 is -2.5, and then you get 1 divided by 4, which is 0.25, and then that plus 5, and we have that that's greater than or equal to this other side. And if you do 7 divided by 3, that's 2.3 repeating x, and then -5 divided by 3 is -1.6 repeating. So this is just kind of a lot of numbers, a lot of decimals. So one other way you can solve these is you can plug both sides into your y equals, and then we can figure out where they cross. So we can type in -10 plus x, -10 plus x divided by 4 for our first equation. And then we can type in 7x minus 5 divided by 3 for our second equation. So now when we take a look at these, we can see, let's see what we did wrong. That should be negative. Okay, so we can graph these and see where they cross, and then that should give us our x value where these are the same. So let's just make sure I typed it in right. Oh, I didn't put the plus 5 right here. So let's get the plus 5 in this one. So make sure, always double check your equations. So I've got the -10x divided by 4 plus 5, and I've got the 7x minus 5 divided by 3. So then when you hit graph, we can figure out where these cross. And the way you do this on a graphing calculator is by hitting second trace, and then you want to find the intersection. So that's option number 5. And then you hit enter on the first line, enter on the second line. Then they ask you to guess. You don't have to, just hit enter again. And we can see that the intersection point here is at x equals 2. So x is the only variable we had in here. So x equals 2 is what produces an equality. If we plug 2 here, it's going to give us 3 back, since that was the y value. And if we plug 2 in over here, we'll get back 3. So that's another way you can do it instead of having to do all the algebra for this part. Number 4, Noah is solving this inequality. First, he solves the equation where he just sets them equal to each other, and he gets x equals 6. So this is the boundary point, right? This is what makes both sides equal. So how does the solution help Noah solve the inequality? So this is our boundary. This tells us when the two sides are equal. Whoops, not 2, 6. So now if we just plug in a number that's lower than 6, we can find out if these numbers below here are part of our solution, or if we want the numbers above 6. So let's plug in x equals 0. So we get 0 plus 5 on the left, and we get 0 plus 35 on the right. So this is saying that 5 is greater than 35, and that is a false statement. So we know that 0 is not part of our solution set. So that means that our numbers that are bigger than 6 are the ones that are in our solution set. So then that means x is greater than 6. And we don't choose equal to because we don't want the two sides to be equal to each other. This is just saying we want the left to be greater than the right. Number 5, which graph represents the solution here? So it looks like we've got kind of two different boundary points. They either have us at negative 3.5 or they have us at positive 3.5. So let's go ahead. I'm just going to solve this because this one will be a little bit easier to solve. And so we can just distribute the 3 in here. So 3 times 2 is 6x and 3 times 4 is 12. So then we can subtract 6x from both sides. And we get 5 plus 2x equals 12. So we can subtract 5 from both sides, and we get 2x equals negative 7 positive 7. So then we'll divide by 2, and we get x equals 3.5. So then we know that A and B are wrong because they're at negative 3.5 for the boundary point. So we know we're here, so then we'll plug in a value. Again, I like to plug in 0. So I'm going to plug in x equals 0 and see if that is part of the solution set or not. And we just go ahead and plug that back into this original equation. So we're going to have 5 plus 8 times 0 is 0. And see if that's less than 3 times. So 2 times 0 is 0. And then we have the plus 4. So this side is saying 5 is less than 3 times 4. And 3 times 4 is 12. So is 5 less than 12? Yes. So that's true. That means 0 is in our solution set. So we want the ones where that line was bolded less than, or that included 0. So we want this one, answer choice D, where 0 was part of our solution. All right, number 6 says solve this system of linear equations without graphing. So we can see that our x terms are the same. They have the same number. So we'll be able to subtract these equations. So we'll do 7x minus 7x is 0. 11y minus 3y is 8y. Negative 2 minus 30 is negative 32. Then we'll be able to divide by 8, and we get y equals negative 4. So the first part of our solution that we know is that y equals negative 4. So now we'll plug that back into either of these two equations. I'm going to pick the bottom one. So we have 7x plus 3 times negative 4 equals 30. So then we have 7x minus 12 equals 30. So we'll add 12 to both sides because that gives us 7x plus 0 equals 42. So then we can just divide by 7 and we get that x equals 6. So our solution to this system is 6, negative 4. Number 7, Kieran has 27 nickels and quarters in his pocket, worth a total of $2.75. Write a system of equation that represents the relationship between the number of nickels and dimes and the dollar amount. So we know that the number of nickel and dimes that he has in his pocket is 27. So n plus d equals 27. Then when we do the cost or the money portion of it, we know that nickels are 5 cents, so 0.05 N. And then, quarters, nickels and quarters. But they said write it for dimes, so I think this is wrong. This should be quarters, not dimes. So let's change that. So this should be quarters. So quarters is 25 cents for quarters. And that should equal $2.75. So now it asks us how many nickels and quarters are in Kieran's pocket. So now we just need to solve this system. So you can do a couple of different things here. I'm going to do elimination. So I'm going to multiply this top equation to cancel out the nickels. So I want to get 0.05 in front of the n. So I'm going to multiply this whole thing right here by 0.05. So 0.05 times 1 is 0.05, and then same for the quarters. So 1 times 0.05 is 0.05. And then we'll do 27 times 0.05, and we get 135. So that's taking the first equation times 0.05. Then we still have our second equation. So now that we have the n's being the same, we'll be able to subtract these equations. And when we subtract them, so we get 0 for n, 0.5 minus 0.25 is negative 0.20. And then 135 minus 275 gives us negative 1.40. So then we'll divide by negative 0.2. And we get that the number of quarters that we have is 7. So we have 7 quarters. Then we just need to figure out how many nickels we have. And remember, the total of quarters and nickels is 27. So if we have 7 quarters, then we have 20 nickels. Number 8, how many solutions does this system of equations have? Explain how you know. So you could go ahead and try solving it to see how many solutions you get. I'm going to solve them both for y. So I'm going to bring this 2/3, I'm going to subtract 2/3 x from both sides. So we're going to get negative 2/3 x plus 4. So then for this bottom one, I'm going to do the same thing. I'm going to solve it for y. So the first thing I'm going to do is actually bring y back over here. So then I'd be at 3y with a positive 2x equals 12. So then I'm going to subtract 2x from both sides. So we'll be at 3y equals negative 2x plus 12. Then I'm going to divide everything by 3. So we get y equals negative 2/3, or 2/3x. And then 12 divided by 3 is 4. And I see that these are the exact same equation. So that means that there are going to be infinite solutions. Because if we were to graph this first equation, a negative 2/3 x plus 4 would be something like that. And then a negative 2/3 x plus 4 would graph right on top of it. So every single solution to one line is going to be the solution to the other as well. Number 9, the principal of a school is hosting a small luncheon for her staff. She plans to prepare 2 sandwiches for each person. Some staff members offer to bring salads and beverages. The principal has a budget of $225 and expects at least 16 people to attend. Sandwiches cost $3 each. Select all of the equations and inequalities that could represent the constraints in this situation. N is the number of people, S is the sandwiches. So A and B are talking about the number of people. So A is saying the number of people is more than or equal to 16, where B is saying it's more than or equal to 32. So we know that this one, she said she expected at least 16 people. So more than or equal to 16 would be correct there. C is talking about the sandwiches and the number of people. So She said that she expects, or she's going to prepare 2 sandwiches per person. So the sandwiches are going to equal 2 times the number of people that show up. So she needs to have S equals 2n, not S is less than 2n. So she wants to have the sandwiches equaling out to 2 times the number of people that show up. Then part E talks about the E and F are look almost the same, except for it has the variable n or s. So this one is saying 3 times the number of people is less than 225, and this one is saying 3 times the sandwiches is less than 225. So this one's actually getting into her budget and $3 for the sandwiches. So $3 times the number of sandwiches needs to be less than or equal to her budget, not the number of people. So F would be correct there. Number 10, students at college are allowed to work on campus no more than 20 hours per week. The jobs that are available pay different rates, but they start at $8.75 an hour, and students can earn a maximum of $320 per week. So this question is asking us to write at least 2 inequalities to represent these different situations. So if we take a look at kind of the 3 things I underlined, I'll just write inequalities for all of these. You just have to write at least 2, so you can do 2 or 3 or more. So for the hours, they can't work more than 20. So if I call H the number of hours that they work, that needs to be less than or equal to 20. So their hours have to be less than or equal to 20. Then the amount of money that they're getting paid per hour, okay, so their pay rate, so I'll call this R for rate, is $8.75 or more, because it's starting at $8.75, which means the rate is going to be at least or bigger than or equal to $8.75. So the rate is greater than or equal to $8.75. And then they're saying that a student can earn a maximum of $320 per week. So the money that they make is going to be less than or equal to $320 in the week. And so you could do it as money. You could also do the money as the hours that they work times their pay rate has to be less than or equal to $320 in the week, since that's how much total money they'd make. But so there's some options for what you could have for your inequalities.